Hi everyone. In this video, I'm just going to talk about some of the most important points of Unit 2.1. In this unit, we were talking about rates and ratios, so I just want to remind you of those definitions. Realize that this whole curriculum in Quantway kind of uses the two terms interchangeably. Most often they talk about everything in terms of ratios, which isn't wrong, but a rate is a special kind of ratio, and I want to make that distinction for you. So a ratio is a comparison of two quantities with the same units. They can be written in words or as fractions, decimals, or even percent. Very often the units are omitted, especially if the context is obvious. So for example, a class in the community center has a 2-to-1 female to male ratio. So when we write the ratio 2-to-1, since we know that we're talking about females and males, we don't have to write the unit of people or talk about what those numbers represent, that they're quantities of people in this case. We could write that also in fraction form and write it as 2/1, or decimal would just be 2. Percent would be, I guess, a 200%, if you're making a comparison of how many females to males. A rate is a comparison of two quantities with different units. So we've started to explore those in the first couple of units in Module 2. So rates are often written in fraction form or in word form, but it's very important that the units are used. So for example, the gas mileage of a 2020 Honda Accord is 38 miles per gallon. So that 38 miles per gallon that you see here, this is a rate because we're comparing the number of miles to the number of gallons. Those two things are kind of equivalent in a way. So having 1 gallon of gas is equivalent to being able to drive 38 miles for that vehicle. In this unit, we talked about population density. So I want you to remember the formula for population density. It is the population divided by the area. Population can be of people. In the exercises, it would just represent like the number of objects, like the number of stars in a particular region. And the area represents the area of that region. The area can be measured in lots of different ways. If we're talking about a city or a state or a country, we might think about area in terms of square miles or square kilometers. If we're talking about a smaller region, we might think about acres or square feet. It's often useful to write population density as a unit rate. A unit rate just means that the denominator is 1. Like in this gas mileage example, 38 miles per gallon, that really means for 1 gallon. So if your rate is not a unit rate, you could always write it as a unit rate by dividing. And when you divide, you're dividing the numerator, the top number, by the bottom number. We do that so that we can compare. So if two rates have either the same numerator or denominator, we can compare them very easily. But sometimes it's difficult to make the numerators the same, and making the denominators both equal to 1 is very simple because we just have to divide. So here's an example. So here are the areas and the number of students for the Grant and the Ammerman campuses at Suffolk. So Grant covers 207 acres and has about 10,000 students. Ammerman, 156 acres, 14,000 students. So the Grant campus is actually bigger in terms of land area, but smaller in terms of the number of students. Now we're measuring in acres here because neither of the campuses is equivalent to a full square mile. It is not. So an acre here as a reference is 43,560 square feet, which is 1/640th of a square mile. So we would need at least 640 acres to make up a square mile. All right, so if we're calculating population densities in terms of number of students per acre, Grant, we're writing it in fraction form. Remember, the population goes on top, so students on top, area on the bottom. So you have 10,000 divided by 207. That gives us about 48.3, and the units are students per acre. Right, so you have to make sure to write the unit there, both units, or 2 units. For Ammerman, 14,000 students divided by 156 acres is about 89.7 students per acre. So even though the Grant campus is larger, well, actually, we have less students at Grant and more area, right? So we have more space. So the population density of Grant should be lower because you should feel more spacious. There are less people. There's more space for you to move around in. At Ammerman, there are more students and less area, so they feel more crowded, 89.7 students per acre. If we wanted to further compare how much more crowded or how many times more crowded Ammerman is than Grant is, we could divide. So if we divided 89.7 by 48.3, divided the population densities, we would get about 1.9, which means that the Ammerman campus is about 1.9 times as dense or as crowded as the Grant campus. All right, so a couple of other things that we did. So let's say that we wanted to make the Grant campus feel equally as crowded as Ammerman. So if we're not changing the size of the campuses, we could change the number of students. So we would need more students to make Grant feel more crowded. And the question is, how many students would need to be at Grant? So we could use the population density of Ammerman. Ammerman was 89.7 students per acre. So for every acre of students, I need about 90, every acre of land, I need about 90 students to occupy that. So I could take that 89.7 students per acre and just multiply by the number of acres on the Grant campus, 207. And that tells me that we would need to have 18,567.9 students on the Grant campus so that we would feel just as crowded as we would at Ammerman. So we would need to have more students than they have at Ammerman. Remember, at Ammerman, they only have about 14,000. We would need to have more students because we have larger area. All right, a couple of things to remember about population density. The higher the population density means the location is more crowded. How the people are spread out or dispersed in the given area doesn't matter. So in the example about the island, if we're considering the whole entire island as the area, if everybody's crowded in the middle at the waterfall, it doesn't change when they spread out evenly if we're still focusing on the entire area of the island. So let's say in the state of New York, instead of having some crowded regions like in New York City, everybody spread out evenly amongst the entire state, and we used, all of the land area upstate and Long Island. Changing the way that we spread out would not change the population density of New York. We would still have the same area and the same number of people. So ways that we can change population density is if, one, only the area changes. So if the area gets bigger and the population stays the same, then you get less crowded, less dense. If the area gets smaller and the population stays the same, you get more crowded or more dense. If only the population changes, that means the density will change as well. If population goes up but area stays the same, then you're going to be more crowded. If population goes down, then you'll be less crowded. Now, if both the area and the population change, but they don't change in an equal way, so the population and the area are not multiplied by the same value or divided by the same value, then the population density will change as well. All right, one of the main mathematical ideas is just how to compare and contrast ratios with a proportion using population densities as an example. So we really used what's called a proportion in this example, where we wanted to use a population density of the Grant campus and then figure out how we could, use the population density of the Ammerman campus and figure out how to make the Grant campus equally as crowded. We actually use a proportion there, even though we didn't set it up like that. A proportion is just a statement that two fractions are equal. So you saw this also in the unit where you looked at the population, or the two fields. You had field 1, where you had a certain number of people standing in a field of 1 square mile, and then you increased that field to 25 square miles and then figured out what the population would be in that third field. Right. And once again, very important every time you have rates. The units are really important. So you should always label for a rate. There will always be two different units, the unit for the numerator and the unit for the denominator. And that goes if you're writing it in fraction form, like you see here, or if you're kind of writing it in text form, you would write it out on one line. If it's a unit rate, we use the word per. Per acre means for 1 acre.